Hello and welcome back to another video. This is IGCSE Chemistry Paper 6 and we will revise some important concepts that you need to know to ace Paper 6. We discussed different apparatus that you need, how can you improve your accuracy and safety, and we also discussed how we can do the planning questions with practical examples. Let's get right into it. Alright, we'll start with some common chemistry techniques that you should know. So first of all, let's discuss about filtration. A filtration technique is used when you want to separate two substances where your solute is insoluble in water. For example, if you have sand and water. So this is the diagram of the filtration process. You have a conical flask and you have a filter funnel on top. Then you also place a filter paper in the filter funnel. And then you pour your mixture through the filter paper into the conical flask. The insoluble particles remain here, so this is called the residue. Filtrate is something that can filter through the filter paper because it's soluble. For example, water. Now, one common question that you can get if for filtration is A, you can be asked to draw this diagram or label one of them. Or one more question is, why is the residue washed with water? This one, why do you have to wash this with water? This is to obtain pure sample, to remove any droplets of filtrate, for example, some crystals here, and this is maybe some chemical. If you wash this with water, you get a pure sample and any droplets of filtrate will get washed away. Now we'll study another process which is chromatography. This is how the chromatography setup looks like. You have a beaker and then you have a glass rod on which the chromatography paper is hanging. So you dip this chromatography paper in a solvent. And the key thing to note about this solvent is that this solvent has to be soluble in your sample. You keep your sample here. If the solvent is not soluble in the sample, these would not separate. Okay, so one thing to note is this. Another thing to note is that this is the baseline, which is drawn with pencil. This is where you keep your samples, like this. One question that you can be asked is, which equipment is used to draw the baseline? You will say pencil. For the solvent, remember, solvent is supposed to be soluble in sample. It should touch the chromatography paper. Remember, chromatography paper is also known as the chromatogram. Chromatography is a process to separate substances, and it can also provide us information to help identify them. Why? Because they have specific RF value. Now, what are your steps? First of all, you have to take your sample and crush it. If it's a solid, you have to crush it. For example, if you have some grass, you take some grass, using a mortar and a pestle, you're going to, and then you will, if it's a liquid, you don't have to do that. And place your sample on this baseline. Now, and then dip your chromatography paper into the solvent. A very important point to note is that your baseline should be above the solvent, so it doesn't dissolve. Okay, and then you will lose your sample. So you leave this setup for some time. After some time, these travel up. They travel to different heights based on their solubilities. Okay, more distance traveled if there is a greater solubility of sample in the solvent. The solvent travels up the paper by the capillary action. Now, using this, you can calculate the RF value. What is RF value? RF value is specific for every substance. So based on the RF value, you can identify which substance was in the sample. So after some time, you might see something like this. You have to calculate RF value for each of these individual dots. So the RF value is distance traveled by the substance divided by distance traveled by the solvent. So for example, if this was 20 and this was 40 centimeters, going to be 20 divided by 40 equals to 0.5. No unit, because this is centimeter, they cancel, so there's no unit. We have something else as well, which is called as a locating agent. A locating agent is used when your sample is invisible. You cannot see the chromatography that has occurred, so you will spray the locating agent on the chromatogram, and the locating agent is going to make the invisible substances visible. It can either make the invisible substances visible or it will fluoresce under UV light. When you put UV light, it will shine. Now this is another diagram of chromatography, but there are 3 mistakes. Can you identify the 3 mistakes? Alright, so the first mistake is that the samples that we have, they are not on the baseline, they are below the baseline. And why is that important? Because how will we calculate the RF value if we don't know the starting point? How will we know that what is our distance traveled? Another mistake is that you can see these three samples, they're not on the same height. If their starting point is different, their final point is going to be different, and it will not again have an accurate RF value. And finally, the last mistake is that if you can see, the solvent is not even touching the chromatography paper. If it's not even touching, the chromatography won't even occur. Alright, now we have another example of chromatography. Can you conclude 3 points from this experiment? Okay, so let's look at the first one. The first one has only one spot. This shows that this was a pure substance. It was only made up of one substance. Now the second one, you can see that this did not even move from the baseline. This means it was not soluble in the solvent. Now we cannot identify anything about it. For the third sample, we can see that it was made up of two substances. Another thing you can notice is that this spot and this spot are the same height. This means both of them have the same RF value and they're both same substances. Now we can move on to another process called as crystallization. So we use crystallization when we want to obtain the solute from the solvent. For example, if you have a salt solution, if you want to obtain the salt from a salt and water, how do we do it? The first step is so you have your solution, right? You put your solution in this evaporating basin and put it on a tripod stand, and then put a Bunsen burner underneath it. So you are supposed to heat your solution. Then when you're heating it, first of all, some water or some solvent will evaporate, making it more concentrated. After some time, you have to keep heating it until it reaches the point of crystallization. What is the point of crystallization? That is where the crystals start to form. In questions like these, you can be asked a lot of 1-mark questions, so it's important that you know them. You should know the labeling of the diagram. You should know what is happening in each of these steps and why is it happening. Alright, so for when you reach the point of crystallization, you're supposed to remove the heat and we're leaving it to cool. And then when you leave it to cool, the crystals start to form, as you can see here. And in the next step, you will do filtration. The crystals will be filtered out as a residue, and the filtrate, it will pass through the filter paper. Now, one more question that you can be asked is, why are you doing filtration? To separate the crystals from the solvent. After this, you're supposed to wash your residue to remove any droplets of filtrate. For example, if it was an acid or some other chemical, you want to remove any traces of that filtrate, you have to wash the residue. After washing the residue, you have to dry it with an absorbent or a filter paper. Now, one more important concept that you should know is titration. Titration is when you mix two solutions. The most common example is perhaps when you mix acid and base. So it can be used to determine the concentration of either of them, either the acid or the base. You can notice how much volume of acid is needed to neutralize the alkali. It can also be used to prepare salts because acid plus base is salt and water. Now, what is the process? You keep a conical flask, okay? And then you use a volumetric pipette. You use a pipette when you need to add a known volume in a flask. So here we need to add 25 centimeter cube accurately. That's why we use this volumetric pipette. We use a filler. This helps to pour it down. The next step is you're supposed to add an indicator. What is an indicator? An indicator is used to identify the presence or absence of something, and it tells us whether it's acidic or basic, something like that. So some common examples are phenolphthalein. Phenolphthalein is colorless when it's in acidic solution, and in alkali solution it turns pink. Another common example is methyl orange. This is also very useful for titration example. In acid it's red, and in alkali it turns yellow. In neutral solution it's orange, okay, in neutral solutions. For phenolphthalein, that's also colorless in neutral solutions. Now, if you have a litmus paper, now remember this litmus paper is not ideal for titration because how are you going to dip it while you are doing titration? In acidic solution, it turns from blue to red, so you have to use a blue litmus paper. It will turn red And for alkali, you have to use a red litmus paper, and this turns blue. Now what do? So after you add your acid, sulfuric acid and indicator in the conical flask, first you keep a white tile on the stand, and then you put your flask, and then you will fill your burette with the alkali. So here we have calcium hydroxide. Open this burette, allow the alkali to come in drop by drop. Make sure that you are constantly swirling it so that it mixes. Now whenever the acid and base have neutralized each other, it will change color. If you have added phenolphthalein, it's going to turn pink. Now what are some points to notice here? We don't use universal indicator. Why not? Because universal indicator changes colors so many times, from very acidic to neutral, so it's very hard to know the end point. End point is where one drop, like one more drop of the base, is going to cause a sharp change. For example, here we can easily identify it, and then we can measure the volume on the burette. Now how we're supposed to remove air bubbles from burette before starting the experiment. How do we do that? Like this, and we have an empty beaker. We run the burette so that if there are any air bubbles, it will be gone. Now you are supposed to repeat until you get consistent volumes. You can draw a table then. So this is how your table could look like. You'll have the initial volume from the burette, and then write down the final volume, and then subtract both of them, final minus initial, to find the volume used. Now what is the volume used? It's 20. This is just a random number. Now it's sometimes you can just continue the experiment. So final volume will now become the initial volume, and then you will open the burette until it changes color. Let's say maybe this was 20. What is the volume used? It's 20. Now you can have 20 here. But make sure after every experiment you are supposed to change the conical flask with a fresh flask. Wash your conical flask, again add 25 centimeter cube of your acid, add indicator, and keep it there. But you can have the same burette. Now you can see, so we're getting consistent results. No, we have some accurate results. Some other points that you can focus on is also simple distillation and fractional distillation. Review the diagram and how it's carried out. Alright, now we will discuss some ways in which we can measure liquid volume. So the first way is that you can use a measuring cylinder. A measuring cylinder looks something like this. But the key thing to notice is that this has very less accuracy. It's usually used when you want to pour a liquid. For example, if you want to pour a liquid into a flask, you can put it in a measuring cylinder, measure it, and then pour it somewhere else. Sometimes when you're asked to read a measuring cylinder, they can even invert it. This is going to be 21. Make sure to see how it's going, okay? Start from the bottom one to go up. Here, bottom, go down. This is going to be 21. For more accurate methods to measure volume, you either have a burette or a volumetric pipette. Now, burette is the most accurate measuring technique when you have variable volume. You can measure 2, 3, 4, all the way from 0 to 50 centimeter cube. It's very accurate. So if you're asked a question, why is a burette used compared to a measuring cylinder? Remember, burette is more accurate. Now on the other hand, what about volumetric pipette? Volumetric pipette looks something like this. It can even have a pipette filler attached to it, something like this. Now a volumetric pipette is most accurate when you have a fixed volume, and it's for smaller volume, 10 to 25 centimeter cube. But remember, it's only for fixed volume. That means you will have a specific pipette for 10 centimeter cube, a specific pipette for 25 centimeter cube. For example, if this one says that this is for 25 centimeter cube, it will only fill 25 centimeter cube. It's very accurate, but the disadvantage is that it's much harder to use, and again, one fixed volume only. So if you see a question where they say why burette was used instead of volumetric pipette, because burette is for variable volumes. Now this was a different apparatus used to measure volumes of liquids. How do we measure volumes of gases? Now we will discuss two different ways when we want to measure gas volume. The first one is the gas syringe. This is your syringe. This is a conical flask. The reaction mixture is inside the conical flask. A reaction occurs and the gas is collected inside this gas syringe. Why do we use that? It's very precise and accurate. It's easy to set up, and the gas remains dry. The gas doesn't touch the water like it does in this method. So this is the downward displacement of water. So you have a conical flask. This is where the reaction occurs. You have a bunk. so the gas does not escape. You also have a bung here. Then there's a delivery tube. This delivery tube is inside this cylinder, inverted measuring cylinder, as a reaction occurs, and this gas is allowed to go there. Gas collects here, and this water goes up. So this is called displacement of water. But the thing is, this can only work if the gas is insoluble in water. If gas is soluble in water, it's going to dissolve and you'll not be able to have a reading. Now there are some cons to using gas syringe. That is, it can be a bit expensive, limited volume only because you have a smaller syringe compared to this bigger measuring cylinder, and sometimes this syringe can stick. In order to measure temperature, you can use a temperature probe. This temperature probe is dipped inside a liquid or a solid. And why would we use that? Because temperature probe provides more precise readings. It's very easy to take multiple readings. Why? Because, for example, as the liquid is heating, as the substance is heating, you can read the change in temperature on your probe. On the other hand, what are some disadvantages? Why would we not want to use that? It's because it can be expensive. It can be more expensive, and also because it's dipped in substances, right? So it can corrode. To measure temperature, we also have thermometers. There are two types, either analog, which are traditional thermometers, or digital thermometers. Remember, digital thermometers are more precise to 0.1 degree Celsius. On the analog or traditional thermometers, you are not able to read temperature very precisely. So the most common method to measuring mass is a digital balance. Remember, this balance, just like a thermometer, digital balance provides us more precise readings. Now there are two sources of errors. First of all, you can have a zero error. So initial reading is not zero. Another source of error is that measuring before you get a constant reading. Now, what are some different ways to improve accuracy? The most common way is to repeat and take average. When you repeat, you are going to reduce chances of errors that were either from your side or because of the equipment, and then take the average. Second, you have to use more appropriate apparatus or setup. For example, if you are using a measuring cylinder, it's better to use a burette because that's more accurate. And then I'll give you one example to show what that is. So first of all, you have your acid in the flask. Hydrochloric acid reacts with zinc, it starts producing hydrogen gas. But how do you make sure that your hydrogen gas doesn't get lost? That you can already put some hang some of the zinc here. And then when you want the reaction to occur, you will just tilt this. So hydrochloric acid comes in contact with the zinc and reaction occurs without any loss of gas. Now there are some ways where you can use cotton. For example, if you have a flask and you can cover this with a cotton. If you have a volatile liquid, for example ethanol, it's not going to evaporate. You can increase accuracy by reducing evaporation. Also, you can use a digital apparatus because if you have a digital apparatus, it's more accurate to read compared to an analog one. Last point, measure mass when reading becomes constant, as mentioned before. Now here are some common ways through which you can improve safety. First of all, these use safety goggles, gloves, and lab coat. This is common for a lot of experiments. If you use safety goggles, it can protect your eyes. To protect your hands, use gloves. If you're dealing with heat, use heat-resistant glove. Lab coat prevents your body. Now, what if you're dealing with toxic flames? For example, if you're dealing with hydrogen chloride gas, chlorine gas, use a fume cupboard. Carry out your reaction inside a fume cupboard. Now, if you're dealing with alcohol, remember alcohol is flammable, so don't put it directly on a naked flame. Don't directly heat it on a Bunsen burner. Use a water bath when you're heating an alcohol. Now, these are some 3 common questions, and let's try to answer them. First of all, why would we crush a substance or material to powder before carrying out the reaction? When we crush, we increase the surface area, more surface area, so this is going to increase the rate of reaction. Why invert measuring cylinder? It again depends on the question. So for example, if there is a question and here they have a measuring cylinder, they added their substances and then they inverted it. Why would they do that? If they want to mix the contents inside the measuring cylinder. Now the next question is, why leave measuring cylinder before taking a reading of the precipitate? So for example, a reaction occurred and precipitate forms inside the measuring cylinder. You give some time for the precipitate to separate from the liquid, and you can easily measure the reading. So if we have these graphs and we are supposed to identify which one is exo and endothermic, we can know that endothermic is this one. Why? Because endothermic takes in energy, potential energy inside it will increase. Remember, endothermic takes in energy, so in the surrounding the temperature will become cooler. Now it's taking in the heat. On the other hand, this is the exothermic reaction. Potential energy of the substances will reduce and it will release heat outside. This is exothermic. Exothermic reaction will increase the temperature of the surrounding. These represent the activation energy. Now moving on, here we have three types of graphs. Now, so on the first graph, this 9 had a steeper graph compared to this one. So this means if we're talking about surface area, this one has a greater surface area. The substance is more exposed to react with the other substance, more successful correlations. That's why there's going to be a greater rate of reaction, as you can see with the steeper graph. However, the volume will be same. On the other hand, if the concentration is different, volume is not going to be the same, the final volume. Why? Because remember, concentration means mole per unit volume. There is a greater number of moles that are going to react per unit volume, so you will have more reaction. Finally, if you have a difference in temperatures, now more temperature means more kinetic energy, successful collisions, a greater rate of reaction. You can see the graph is steeper. However, again, volume will be same. Sometimes you will be asked to draw two lines like this. For example, make sure that you label that this one is experiment 1, the other one is experiment 2. Sometimes you will even need to extend the line to 0, 0. Everything is going to be mentioned in the question, so make sure that you spend your time and understand the question properly. Then sometimes you will even have to extrapolate like this to find the common point and identify the time maybe or whatever that is. Now for test of gases, flame test, and qualitative analysis, this is given in the end of your paper 6, but make sure that you read it now so that you will be prepared in the exam. Remember to read what these are. Ammonia turns red to litmus paper to blue because when mixed with water, like as it says here that is damp, it becomes alkaline or milky. Now another name for lime water is calcium hydroxide. Chlorine bleaches a damp litmus paper. Remember, it's supposed to be damp. For example, if they ask you if it was dry, will it work? No, it has to be damp. For a flame test, these are your metal ions, the cations, and these are the flame colors. There was a question in the exam which said, how can you do flame test? You need a blue Bunsen burner flame. The blue flame is non-luminous. Okay. Next, dip your unreactive metal wire into the substance and then expose this metal wire on the flame. I have made a video about this. You can check it in the description. If it was orange red, it means that some ions were present. Next, for qualitative analysis, again these are given, but it's a good idea to go through them at home and practice as many questions as you can. Some things that you can remember is that if you see barium, it's for sulfate. If you see nitrate, silver nitrate here, silver nitrate, this shows that they're testing for a halide. If they're testing for carbon dioxide gas, it means there was a carbonate present. Remember, all sulfates except lead, barium, and calcium are soluble. That is why when you have sulfate, we form sulfate barium. This is a white precipitate. All nitrates are soluble. That's why we don't have a precipitate with nitrate, we have a gas. And then all chlorides except lead and silver are soluble. You can see in chlorides we're using silver nitrate and we get a white precipitate. Alright, so the planning question, usually the last question in the chemistry paper 6 exam, is for 6 marks. It can be a bit tricky. If you deal with that question properly, you can get a lot of marks. It's a good idea to learn the common apparatus, and then you can revise common chemistry techniques. Learn all the separation techniques, for example, filtration, titration, and all of that. Also learn how to do electroplating. There was the recent question was one of that, and all of that. And then review some formulas. Remember the formula for moles, for the percentage composition by mass, and all of that. Now, to ace a planning question, it's a good idea to review all the latest planning questions quickly, as much as you can. That's going to really help you and prepare you for this exam. Now, There are different ways to approach this question. One way is that in this way. So first of all, when you read the question, read it carefully. In your brain, try to identify the method. Do you need to do chromatography for this one? Do you need to do electrolysis? Also, review electrolysis, okay? That can also be useful. Also, identify the apparatus. You don't need to list all the apparatus in the beginning. Include all the names of the apparatus in your answer. Secondly, think how are you going to do that method. If you're standing in a lab, how will you do it? Do you need to crush your mass? Do you need to heat something? What will you do? Which apparatus are you using? Now this is the time to mention your apparatus. Next, mention how are you going to measure the mass and volume. What's your independent and dependent variable? Are you changing the mass? How are you going to measure the mass? If you are measuring the volume, how are you going to measure the volume? If you're measuring the volume of gas, for example, you can say use a gas syringe. Okay, and think logically and say what will you do. And then you can also say use known concentration of volume. When your independent variable, the one that you are using, you can use a known concentration of volume. And then mention, is there any control variable that's important? Do you need to make sure that the temperature is same or something like that? Look at your experiment. And then to increase accuracy, repeat 3 to 4 times and then take the average result. Finally, you have to say how are you going to analyze result. For example, maybe you need to use a formula, for example this one, or maybe you can observe the change. Maybe there was a higher rate of reaction for experiment 1 compared to experiment 2. So this is an example from a recent paper. Beetroot is a colored vegetable. The color is caused by a mixture of water soluble colored compounds. Now can you identify the method already? Of course, it's a colored compound, it's a mixture, so we'll do chromatography. Now plan an experiment to find how many water soluble colored compounds there are. In your plan, say how to extract the color compounds from the beetroot, how to separate the mixture of colored compounds, how the results show how many colored compounds there are in the beetroot. So how are you going to do the method? Think logically. Apparatus you can even draw is going to help you. Now you cannot directly put your beetroot on the chromatography paper, right? So of course you need to crush it. How are you going to crush it? Think logically. You need some apparatus. Use pestle and mortar. Now it's crushed, mix it with water. So you get a solution kind of. Then on the chromatography paper, you will put the drops of beetroot solution that you have. And then when you do that, you will perform chromatography. Draw a baseline with pencil. You can dip your chromatography paper in water. Allow chromatography to occur. And how are you going to analyze the result? The number of colored substances represent the number of spots. Alright, now we have one more example. Oxalic acid is a white solid which is soluble in both water and ethanol to form a colorless solution. Plan an experiment to determine if oxalic acid is more soluble in water or in ethanol at room temperature. So you have to react oxalic acid, which is a solid, to both water and then with ethanol. First react with water, then react with ethanol, and then find out which one is more soluble in water. Your answer should include how your results will tell you if oxalic acid is more soluble in water or in ethanol at room temperature. Now, first of all, identify the method. You have 2 beakers, add water and ethanol. Think logically. If you're in the lab, will you just pour water directly? No. You have to pour a known amount of water and you have to measure it first. For example, you can use a burette and pour equal amount of water. Why equal? So that it's controlled. You will add your oxalic acid in water as well as in ethanol. You need to have a known amount of oxalic acid, right? If you add more oxalic acid in one and less oxalic acid in another, it's going to affect your reaction. Then you're supposed to mix them up, and then not all of it may have reacted. Filter and find mass of solid left. If oxalic acid was more soluble in water, you will have less oxalic acid would be left. If oxalic acid was more soluble in ethanol, less oxalic acid will be left here. There are other methods as well. You can read them. And this is for 6 points, so you need at least 6 of these points.